Okay, so let's take a look at these two examples. What is here on the left? I'm going to zoom in a little bit. So suppose f of x is the natural exponential e to the x. First one says calculate the linear approximation of f at a equals 0, and then plot your result. Great, so quick little reminder, what is the linear approximation? It says f of x is approximately its value at a plus the derivative at a times x minus a. Remember, this part itself as a function of x is called the linearization of the function f of x, whereas this entire approximation is called the linear approximation. Okay, so that's enough of the quick little review there. And this is really what we're going to use for both of these examples and all of its subparts in this video. Great, so we need an a value to actually calculate this linear approximation. So that's given to us here, a equals 0. So I'm going to write over this approximation with a equals 0 and then follow what the math tells me to do. So I need two pieces of information, f of 0 and f prime of 0. We know f of x is e to the x, so f of 0, e to the 0, that's 1. And then we have to find the derivative. Remember that the derivative of e to the x, it's a very special function. Its derivative is itself, so that's nice. So that tells us that at x equals 0, e to the 0 is 1 again, so f prime of 0 is 1, f of 0 is 1. So I take those pieces of information and I put them in here, and I get f of 0, that's 1, plus f prime of 0, that's also 1, and then times x minus 0. So that's really just 1 plus x. So that is my linearization. Now, if I go back and put back in what f of x is, e to the x, this is my linear approximation.